All right, so we're doing number 16. We're going to find the positive root correct to 6 decimals of this function. And so we're going to use Newton's method to do this. So let's subtract x from both sides. So now we're going to let that function on the left be our f. So 3 sine x minus x is our function, and we're going to find the roots using Newton's method. Okay, so remember with Newton's method, all right, give me a second so I can write out the formula in Word. It's always nice to write out the formulas because then you know exactly what you have to find. All right, so there you go. Oh, geez Louise. Let's see how forgiving they'll be. Pretty forgiving. Okay, so give me 1 second, guys. 1, 2. And I need a derivative. All right, so that's Newton's formula, Newton's method. So we have our f. So what we're going to have to find next is your x of 1, your starting point, okay? In addition, let's write this. So instead of f, we have the function we're using. So let's write it relative to our function. And our function is 3 sine x minus x. So it's going to look like 3 sine of x to the n minus x to the n. Okay? And then the derivative of that is going to be 3, derivative of sine is cosine x to the n. And the derivative of x is just 1. All right? So that's what we're doing. And we're going to use this whole expression in our calculator. So I'm just going to write it one more time down here so we can refer to it very quickly. All right. So first we have to find x1, and we can find x1 using the IVT. We want to find one value that's positive and one value that's negative. So I just sometimes stare at a function and just to see how it works, and I see we have a sine function. Sine varies between 0 or -1 to 1. So I'm gonna maybe try out where the sine is 0. So I might plug in a 0. Oh, but that would give us 0. So I'm not going to do that. I'm going to do and look at this because we want the positive root, right? And 0 is not positive, it's not negative. So let's stay away from the 0. But I know at pi over 2, the sign is 1. So this is going to be 3 minus pi over 2. That's going to be bigger than 0. And then I'm going to mess around with where sine is -1. So it'd be -3 minus pi in this case, and that's going to be a negative number. So again, just kind of messing around with the sign. I'm gonna mess around where sine is 1 and where sine is 1 and where sine is negative. All right, so I don't know if I said that correctly. Let me write it out though. Okay, so I'm gonna do the pi over 2. And f of pi over 2 is going to be 3 sine of pi over 2. Actually, I know I misspoke. We're going to focus where sine is 0, not -1. All right, and we can do that in our calculator. Or again, sine of pi over 2 is 1. 3 times 1 is 3. Minus pi over 2, that's going to be positive. And we can always throw it in our calculator. It ends up being about like 1.4 something. And then alternatively, we can plug in where sine is 0, which happens at pi. So that whole thing becomes 0, and then we're looking at -pi, which is definitely negative, okay? So again, just a little bit of number sense. And now we know that a root, okay, so let's start over. So now we know that f of pi is less than 0 is less than f of pi over 2. What is going on? There we go. Okay, so that means, again, there is a root between pi over 2 and pi. All right. So let's choose. We're doing that to find an x1. Let's choose x sub 1 to be pi over 2. Okay? And now that we have our x of 1, we can figure out our x2, our x3, x4, et cetera, until we get how accurate? Until 6 decimals are steady, are stable. Okay, so we have our x1, and then we know x2, we're going to find using Newton's method. So x2 is going to be equal to x1. So x1 is pi over 2 minus, and then we have our function. I need parentheses around my numerator. All right, so just plugging things into our function, and then I'm going to plug in pi over 2 to the derivative. Okay. And then this one's not so bad. We can actually do this by hand because sine of pi over 2 we know is 1. Cosine pi over 2 is 0. And if we put all of that in, we're actually just going to get out 3. Okay, and then we would rinse, wash, and repeat. And then after that, of course, it starts getting crazy. But look at how we're going to do it using our calculator. We are going to type in this formula into our calculator, but instead of xn, we're going to use x in our graphing calculator. Scientific calculators might be able to do this as well. But remember, if you don't have a scientific calculator, you're just going to have to plug it in like this every single time, right? Updating your x of n. So you can totally still do it on a scientific calculator. But let's get out our scientific calculator, okay? And then here's the x we're going to use. And the first thing we're going to do is whatever our xn is, we're going to store it as x. So notice in this first case, x1 was pi over 2. So I'm going to do second pi divided by 2. And some scientific calculators have this ability too, where you can store numbers. But I'm going to store this number, STO, arrow, store. I'm going to store it as x. So now that's my x. Okay, and then I'm going to type in that function for xn. Where is it? This one at the top. Okay, I'm going to do x. Oh, don't do that, calculator. X minus, hold on. Let me just try to clear everything. Okay, and I'm going to need parentheses around my numerator. So parentheses 3 sine of pi over 2. I'm going to hit second pi. Oops. I take that back. Don't hit pi. Hit x. 3 sine x minus x. Okay, and then that is our function f. And then we're going to divide it by the derivative. Divide by the derivative in parentheses, which is 3 cosine x minus 1. Okay, and in parentheses. And I'm going to hit enter. If it's not 3, it means I'm in degree mode, and I'm going to go change it. But it's 3, so I know I'm in degree mode. Mode radian. It means I'm in radian mode, excuse me. All right, and if you weren't, you can always just navigate down and hit enter. Okay, but we are. Okay, so look at this. So now 3 is x2. So we would write down what we wrote down before. X2 is equal to 3. And now do this. Go down to the store button, STO store. You're going to store it as x. and then you hit enter. All right, so now this is telling us that x is equal to 3. And remember, 3 is x2. So we're going to redo this line, but now x is 3, because that's what x2 is. And then if we go through that cycle, we're going to get x3. So we can write it out again if we want, but we can be clever too. Notice above the enter, it's the entry. So I'm going to go second entry. I'm going to do it one more time, second entry, to get what we need, and then just hit enter. And that's our x3. So I'm going to write that down. All right, so we had x2 was 3. We just did x3 on our calculator, and it was 2.3509686. Okay, so we are going to now store that as x, and then hit second enter. Second enter. All right, so now we're going to plug in x3 to get x4. And there's x4. Let's write that down. So 2.28068. 66. Okay, so let's store that as x. So now x is equal to x sub 4. Let's run another cycle. Here's your x5. Let's write it down. Oh, you can also store it as x as well. So now x is equal to x5. Okay, and remember on the exam, I'm going to want to have all of these little values. 2788639. Okay, so we just stored x as x5. And now let's do second enter. Second enter. So we're plugging in x5. We're going to get x6. Okay, we're starting to get some stability. I'm going to store x6 as x. I'm going to write it down. Okay. Good. All right. And now let's see if x7 gives us some stability with the 6 decimals. So enter now for x7. So 2.2788627 with the rounding. 2.2788627. Okay, and we want to be accurate to 6 decimals. So we have 1, 2, 3, 4, 5, 6. So again, our first 6 decimals were stable by x7. So then that's our approximation. So what is the positive root to correct to 6 decimals? If we were to plug in that x, that would give us our 0. So that's your solution. So I'm just going to make that in bold. So that's your solution. And it's always nice to check. Let's go back to our original function right here. 3 sine x minus x should be 0. I'm just going to, this is bonus round, guys. This is us kind of checking our work. I'm going to store that as x. Let's plug in our original function, 3 sine x minus x. Whoops, there we go, minus x. And we just plugged in our, see there's f, right? 3 sine x minus x. We just plugged in our approximate solution, x sub 7, and it should give us something really close to 0. Oh, with rounding error, our calculator is only so powerful. With rounding error, it gives us exactly 0. So that's awesome. So that's how we can do Newton's method with our calculator. And we can see with the store function and second enter, Newton's method is actually a lot easier than if we were just using a scientific calculator. So again, graphing calculator is helpful, but we can still do it using just a scientific calculator.